Alrighty, in the last video, we just talked about how, okay, I can use the algebra tiles to turn a product like so, which represents the area, and then rewrite that area as a sum, again, using the algebra tiles here. Now, we don't have to use the algebra tiles, although I do think they are neat for helping us. But here's how we can do it without the algebra tiles. And so we could use the same example, but I think instead we will use well, actually, let's just use the same example because we can see how we can then compare it to the same process. Okay, so what I'm going to do is I'm just going to actually take this rectangle and move it down a little bit. Okay, so first off, we have to start off with the product. So we know the product already. The dimensions of this thing are, like we said, x plus 3 by y plus 7. Okay, and I'm going to ask us to just kind of blur our vision just a little bit and kind of ignore how each of the 4 sections are broken up and just think of the 4 sections. So what I mean by that is we're actually just going to kind of delete this picture, but just look at it like so. So here's a rectangle. I'm drawing it in red here, and I'm going to delete the rectangle. Sorry, I'm going to delete the algebra tiles in a second here. Just break it up into 4 pieces, like so. And of course, they combine to form one giant rectangle, like so. Like this. Okay. I'm going to delete it again in a second, but check this out. Notice how were able to break up the side length from x plus 3 into there's a piece that was x, and there was a piece that was 3. If we remember correctly, this was broken up like so, where this section right here was x, and this right here was length 3. Similarly, on the bottom side, we broke up the y plus 7 into a y piece and a length 7 piece. 7. Like so. Alright, check this out. Now, I delete that picture. I'm going to delete these little frames right here. What we did, remember, is we wanted to find the area of each of the entire rectangle. And so with that rectangle, we could split it up. We could split it up into algebra tiles, in which case we split it up into like dozens of pieces. But we could also do it if we split it up into only 4 pieces, like so. Right now we have just 4 pieces. Check this out. The dimensions of this piece right here in the bottom left corner, its dimensions are x by y. And so that corner piece, the area of just this corner piece, the area is equal to just x times y, or xy. Come back over here. Remember, if this length is x right here, this length is x, then this length right here is also x. If that is indeed the case, then the area of this bottom right piece would have to be what? Well, it's 7 wide by x tall, so the area of this must be 7x. Oops, 7x. Likewise, in the top left side, this little side would also be y, because again, it's a rectangle, so if one side is y, the opposite side is also y. That would mean that the area of this top left piece would be 3 times y, or just 3y. The final piece, again, this rectangle now is 7 by 3, and so the area would be 3 times 7, which is 21. And so again, the area, once again, the area as where am I gonna put this? Put it down here. Equals, as a product, again, x plus 3 times y plus 7. Product would be, again, x plus 3 times y plus 7. But or as a sum, I can just add up these 4 areas. So my area would be 7x plus xy plus 3y plus 21, and this is a sum. This process right here, using this visual, this thing kind of has a name, and the reason I'm bothered telling you the name is because if this video isn't helpful to you, you can maybe look up somewhere else. But this is called a generic rectangle because it's generic because I didn't bother shooting or drawing in all the algebra tiles, but it'll work either way. Okay, maybe we could try one more example here. Let's multiply something like this. X plus 3y minus 1. I'll say minus 1. This is weird because it's minus, but it still works the same. Times 3x minus or plus y. Pretend. Okay. So try this one out. Pause the video for a second. Try it out, and come back. And I'm gonna assume you just did that. So let's draw this. So the number of terms, by the way, tells you how many sections you're gonna split up that side length into. So just for me, I usually put the first one on the vertical side and the second one on the horizontal side. That's just me. It doesn't matter if you do it that way or you rotate it. But this side length right here, actually I'll do it in different colors. Well, maybe I won't do different colors. This one right here, again, generic rectangle. So you're just going to draw a rectangle. Doesn't matter. Doesn't have to be super neat. We just know it's a rectangle. It's a tool, remember. Just a visual of how to multiply. Okay, the horizontal section is a little bit easier. It's going to get split up into two pieces. It's 3x and then a y side, and we'll get split up into two. Like so. X plus 3y minus 1, so that'll be 3 pieces. So check this out. And you can go from the bottom up, or you can go from the top down, or bottom up, or top down. There you go. It'd be x, again, plus 3y, and then plus -1. Now, that seems weird, so, but remember, this is just a visual representation of this. So it's okay that it kind of doesn't quite make sense that way. It's just a side length of -1, which is all good. By the way, you can represent that with the algebra tiles, like so, by just clicking it right here. Okay? Alright. If that's the case, then, again, this rectangle, right here in the bottom left, its area would be, well, -1 by 3x, which is -1 times 3x, which is -3x, like so. Sorry, that's really messy. Like so. The one next to it would be -1 times y, which is -y, or -1y. Keep going. We'll keep going up. 3y times 3x. So the 3 times 3 will be 9. And x times y, well, I can't do anything more than that, so because I don't know what x and y are, so I'll just leave it there. Let's see, this part would be 3x times y, which is just 3 times x times y, or 3xy. Again, can't do anything about that. This would be x times 3x. So remember, again, we're multiplying here, so that's just 3x squared. If I was adding, it'd be 4x, but I'm not adding here. And the last part is just x times y, or just xy. So now, we have our product as we have our area as a product. Again, this is a product. And if I want it as a sum, let me move this over. Product. That is equal to this, which is a sum, which I just have to add up all the areas. So again, alphabetical order, and then decreasing power. So 3x squared, right? That's this one. Check. I usually like to check them off so that I know which one I've used. Let's see. Then -3x. Okay. Let's see. So I've used this one. Now I have xy terms. So now I'm going to have to collect the like terms here. So I have 9xy plus another xy. So that's 10xy's altogether. And then plus 3 more. So that's going to be 13xy's altogether. And then the last part here is minus y. And so that is your area as a product. So again, these two expressions here, they're the exact same value. They're just two different ways of looking at the area. Okay, so hopefully this video helped, and now hopefully you're ready to tackle a couple of your own problems where if I give you two polynomials, two expressions like this, we can just multiply them. I did want to take 1 second actually to talk about how this actually comes up, because you actually sometimes do this on your own. Because what if I want to multiply these two numbers? 13 times 12. So this is one of those weird cases, because I know if it was 12 times 12, I just kind of remember that one. It's 12 squared, which is 144. 13 squared would be 169, but what's 13 times 12? We could actually break them up like so to make our lives actually a little bit easier, because I could think of 13 as 10 plus 3, and then 12 as 10 plus 2. This looks actually awful similar to what we had just talked about with splitting this up, like so. So we could actually do that here to actually solve this problem. So if I split it up, here's my generic rectangle. I have 10 plus 3, 10 plus 2. You can see here, the top left corner, that's 10 times 10, which is 100. The bottom one is 3 times 10, which is 30. 20 up here, and then 6 over here. If I add this up, again, this is the area as a product. As a sum, let's see, 100 plus 20 would be 120, plus 36 would be 156, which actually is what this is. So that's just there. I wanted to show you an example of how this property actually works. Even it doesn't have to be just x's and y's and all that stuff. This actually works with just straight up numbers.